Using Pythagoras' theorem to solve two-step problems. Our first problem is this: find the missing length x to one decimal place. Well, we've got this irregular quadrilateral here, but what you may notice is that actually it's split down the middle here, with a right angle for this part of the shape and a right angle for this part of the shape. So we could view this as a compound shape. Well, in order to approach this problem, let's figure out how we can approach this using knowledge we already know. Well, we know Pythagoras' theorem, which deals with sides with right angle triangles. And here you can see we've got a right angle triangle. We've got a side that we're looking for here. We've got a side length given, but we don't actually have a side length here. So in order to find the side length x, we need to be able to find this side length here. Now this triangle and this triangle both share this side. So what we can do is just focus on this triangle here. We've got a side length, another side length, and we can actually find this side length here using this information, which will give us the side length for this triangle. So let's do the first part of the problem. I'm going to actually colour this triangle in green. I'm going to redraw it here. So we've got 6 centimetres, 4 centimetres, and we'll call this side A. So focusing on this green triangle, it's a lot more manageable at this point because we can just use the Pythagoras theorem normally. So firstly, let's write down the Pythagoras theorem, which is a squared plus b squared equals c squared. Label our triangle. Well, we've already called this side A, so I'll call this side B and this side C. Remembering this is the hypotenuse, so it's always going to be side C. Substituting our values, so we've got a squared plus b squared, which is 4 squared, equals c squared, which is 6 squared. Let's calculate our values in full, so we'll have a squared plus 16 equals 36. Now we want to get a on a side on its own, so we need to get rid of this plus 16 by doing the inverse, which is taking away 16 from both sides. So we'll have a squared equals 36, take away 16, or a squared equals 20. Now from a squared, we need to get just a. So in order to do that, we need to do the inverse of squaring, which is square rooting, and we do that to both sides. So we'll be left with a equals the square root of 20. Now if you put that in your calculator, it'll give you a value of either 2 root 5 or the numerical value of a equals 4.472135955. Now as a quick little check, let's have a look at 4.5 centimetres. Does this seem like it would be the correct length here? Well, we've got a length of 4, a length of 6. Well, actually 4.5 does look like it would be correct there. So it's a nice little check you can do to make sure you're on the right track. But for part 2 of the question, we'll keep the number in the form root 20 because it'll be much nicer and a lot more accurate. So we now know this side length, which is root 20, so we'll pop that there. And we can draw our second triangle. So I'll draw one here so we can base our working out on that one. Put in the information, so we've got 9 centimetres, root 20, and x. Write out Pythagoras' theorem, so a squared plus b squared equals c squared. Label our triangle. Well, I'm going to call this A, this B, and this C. This has to be C anyway. Substituting our values, so we've got root 20 squared plus b squared, which is 9 squared, equals c squared, which is x squared. Because it's nice, I'm going to write out the values in full. So root 20 squared ends up becoming 20. 9 squared is 81, equals x squared. 20 plus 81 is 101, so 101 equals x squared. Square root both sides to get x on its own, so we'll end up with root 101 equals x. Pop root 101 into your calculator and you'll end up with 10.049875562. So that equals x, but we want our answer to one decimal place. So our final answer will actually be x equals 10.0 centimetres to one decimal place. And because the question's asking the answer to one decimal place, keep this 0.0 in still, so it's obvious you have still rounded to one decimal place. For our second question, triangles ABD, so that's this one here, and BCD, so that's this one here, share a side BD. AB is 3 metres, AD is 2.5 metres, and BC is 2.1 metres. And it's asking us to find the length of AC. C. I shrunk the writing down so we've got more space on the page. Looking at this question, if it wants us to find the length AC, well, we've got the length from A to D, but we just need the length then from D to C. So what I'm going to do, I'm going to call DC X. And I'm doing this because I just find it easier to label a side with one letter. So if we need this length here, well, we've got this length, however, we've not got the length BD. So we need to find this length. And in order to find that, we're going to have to refer to the triangle on the left, because we've got one side we've been given here and another side here. So we can actually find the length BD using this left triangle. I'm going to draw out this left-hand triangle. I'll do it in orange. So we've got 3.0 meters, 2.5 meters. I'm going to call this side A. You can call it B if you like. I'm just using A. Use Pythagoras' theorem. So we've got A squared plus B squared equals C squared. Label the other side. So we've also got B, and this side has to be C. Substituting the values. So we've got A squared plus B squared, which is 2.5 squared, equals C squared, which is 3.0 squared. Take away 2.5 squared from both sides. So we've got A squared equals 3.0 squared minus 2.5 squared. A squared equals 9 minus 6.25. A squared then equals 2.75. To get A, we square root both sides, so A equals the square root of 2.75. Now when you put root 2.75 into your calculator, it will probably give you this value here, root 11 over 2. The numerical value will be 1.658, etc. So looking at 1.658, will that fit into this value here, or this side length here? It does look right, so we're going to assume that we're doing something right. Now we've got three values that are the same. Which one of them you use to carry forward with the question is entirely up to you. For this question though, I'm going to use root 11 over 2 because I like it. It's in a nice accurate format and it doesn't have roots with decimals in it. If you're going to carry forward the numerical value, then I would recommend doing it to at least 2 more decimal places than the question asks you to. So if this says 1 decimal place, I'd carry forward at least to 3 decimal places. So for this question, it would be 1.658, as you'll get a higher level of accuracy as you go forward with the question. So now we've got the side length of BD. I'm going to write that on the triangle, so root 11 over 2. I'm going to draw this part of the triangle on its own with the details, 2.1 meters, root 11 over 2, and x, because it's just much easier to work from that. Write out Pythagoras' formula, so A squared plus B squared equals C squared. Label the sides of the triangle, so I'm going to use that as A, B, and C. Substituting the values, so we've got A squared, which is a root 11 over 2 squared. Some of you may have preferred to stick with the root 2.75 or the 1.658 value. Plus B squared, which is x squared, equals C squared, which is 2.1 squared. Take away the root 11 over 2 squared from both sides, so we'll have x squared equals 2.1 squared minus root 11 over 2 squared. Now I'm just going to type this whole expression into the calculator in one go. So we'll have x squared equals 1.66. Square root both sides. So we'll have x equals root 166 over 10, which equals 1.288409873. So I'm actually going to round this to 1 decimal place, as we'll only need that for the final part of the question. So we've got x, or actually it's the length DC, equals 1.3 meters. Now this isn't our final answer, because we want to find the length of AC, but we've only just found the length of DC. So we need this whole length, but we've now been given the length AD, and we've worked out DC. So the length of AC is the length of AD plus the length of DC. So the length of AC is 2.5 plus 1.3. So our final answer, AC, is the length 3.8 meters to 1 decimal place. Our final question, the irregular quadrilateral has a missing side x. Find x to 1 decimal place. So it may look a bit trickier. Same principles as the questions before. We've got the side length x here we're trying to find. We've got a given side length which is 5 kilometers, and we've got no side length on this side here. Now this side shares a side with this triangle here. So we can use this triangle to find out what this side length is. So I'm going to draw out the left-hand side triangle first. We've got 14 kilometers. I'm going to call this A because I seem to like calling it A. 11 kilometers at the bottom. This will be B, and the hypotenuse is always C. Write out Pythagoras' theorem. A squared plus B squared equals C squared. Substitute in the values. So A squared plus B squared, which is 11 squared, equals C squared, which is 14 squared. Take away 11 squared from both sides. So we'll have A squared equals 14 squared minus 11 squared. A squared therefore equals 75. Therefore A will equal root 75. Your calculator may show it in the form 5 root 3, which is the exact same, or the numerical value of 8.660254038. Like the other questions, to keep as much accuracy as possible, I'm going to leave it in this surd format. Now you can use either root 75 or 5 root 3. I'll keep it as root 75 as it's a bit nicer to work with. So now we've found A, we can move on to the right hand side triangle. I'm going to redraw it. Write in the values, 5 kilometers, X, and root 75. Write out Pythagoras' theorem, which is A squared plus B squared equals C squared. Label the triangle, I'm going to call it A up here, B at this side, and this side always is C because C is the hypotenuse, which you know is because it's facing the right angle. Substitute in the values, so we've got 5 squared plus B squared, which is X squared, equals C squared, which is a root 75 squared. I'll calculate these values, so we've got 25 plus X squared equals 75. Take away 25 from both sides, so we'll have X squared equals 75, take away 25, or X squared equals 50. Square root both sides, so X equals the square root of 50. And because we're after the numerical value at this point, type root 50 into your calculator, you'll end up with 7.0710678112. So our final answer will be X equals 7.1 kilometers to 1 decimal place. That's all for this video. Check out the next video for 3D Pythagoras. Like this video if you found it helpful. Subscribe because that will be helpful to me. Other than that, stay safe and healthy, and I'll see you in the next video.